Assalamualaikum and good morning everyone. My name is Sharifah Fasha Kistina binti Syed Zainal Abidin. I'm from class DKA 3C. My matrix number is 0624F1068. So today I will present about fundamental principles and application of momentum in pipe flow analysis. I will cover three subtopics: Newton's second law in fluid flow, force exerted by fluid jet on a flat surface, and application in pipe bends and elbows. In fluid mechanics, the concept of momentum helps us understand how fluids behave when they move or change direction. Momentum can be described as the amount of motion a fluid carries. Using Newton's law of motions, we can determine how much force is produced when water accelerates or changes direction inside a pipe or a jet. This understanding is very important for civil engineers because it helps us design systems like pipeline, nozzle, and turbines that are both safe and efficient. Newton's second law tells us that force equals the rate of the change of momentum. In fluid mechanics, it means that when fluid velocity or direction changes, a force is produced. For example, when water flows through a nozzle and speeds up, a reaction force acting on the nozzle. When a jet of water strikes a flat surface directly, its velocity becomes zero. This causes a force to act on the plate. The formula is force equal to mass flow rate times velocity. Let's see a simple example. For example, if water flows at 10 meters per second with a flow rate of 0.005 cubic meters per second and the density is 1000, we get force equals to 1000 times 0.005 times 10, which gives 50 newtons. So the plate experiences a 50 newtons force. In this second example, when the flow rate increases to 0.01 cubic meters per second and velocity to 15 meters per second, the resultant force on the plate becomes 150 newtons. This means higher speed or flow rate will increase the impact force. In this final example, even with a small flow rate of 0.002 cubic meters per second but a higher velocity of 20 meters per second, the force is 40 newtons. This example shows how both velocity and the flow rate affects the momentum and resulting force. In pipe bends and elbows, the direction of flow changes, causing a change in momentum. This creates a reaction force on the pipe supports. Engineers must calculate this to make sure the system is strong and safe, especially in pumping or water supply system. In real life, the principle of momentum in fluid is widely used. Jet engines work based on fluid momentums to produce thrust. Hydraulic turbines convert the momentum of flowing water into the mechanical energy to generate electricity. Fire hoses or jet cleaner rely on high momentum water jets to remove dirt or control fires. In civil engineering, we also apply momentum principles when designing spillways and dams to safely control water flow energy. To conclude my presentations, the principle of momentum plays an important role in analyzing how forces act on fluid emotions. By understanding and applying Newton's laws, engineers must be able to predict and calculate the forces that occurs in different fluid systems. This knowledge helps us design structures that are not only safe and efficient but also sustainable for long-term use. As future civil engineers technicians, understanding this concept helps us make better design decisions and become more responsible engineers.
What is the main difference between Newton's second law and third law in fluid flow?
That's a good question. Newton's second law relates force to the rate of change of momentums. It helps us calculate how much force acts when the fluid velocity changes. Newton's third law, on the other hand, explains for every action, there is an equal and opposite reactions. For example, when water pushes on a nozzle, the nozzle pushes back with the same force.
How does changing the velocity of the fluid affect the force on the surface?
When the velocity of fluid increases, the momentum of fluid is also increases. Since force equals to the rate of change of momentums, higher velocity means a greater force on the surface. This is why faster water jets creates a stronger impact. I think that's the end of my presentations. Thank you for listening.